Section 7.3, double angle, half angle, and reductions. In this section, you will use double angle formulas to solve equations, verify identities, and find exact values. Use half angle formulas to solve equations, verify identities, and find exact values, and also use reduction formulas to simplify an expression. Now, we're going to add more types of identities that we will use for this section. The first one, the double angle identities. And these are all the summary of those identities. Sine 2 theta is equal to 2 sine theta cosine theta. Cosine 2 theta is either of these 3 cosine squared theta minus sine squared theta, or 1 minus 2 sine squared theta, or 2 cosine squared theta minus 1. And tangent 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta. And let's use this to answer problems example number 1. Given the tangent theta is equal to negative 3/4 and theta is in quadrant 2, find the following. So tangent in quadrant 2. So this is quadrant 2 and it's negative 3/4. So let's say this is our theta. So it's like we have, so given negative 3/4. So if this is our angle, so this is opposite over adjacent, so 3/4, and let's say in quadrant 2, so this is going to be negative 4, and using Pythagorean theorem to solve for the missing side, which is the hypotenuse, so that is 3 squared plus negative 4 squared is equal to the missing side. C squared. So 3 squared plus negative 4 squared is 25, and square root both sides, so this is equal to 5. So the hypotenuse is 5. Okay, so let's use our double angle formulas. For letter A, sine 2 theta, that is equal to 2 sine theta cosine theta. So sine theta, so our theta sine is SOHCAHTOA, opposite over hypotenuse, so that is 3/5. Cosine is adjacent over hypotenuse, so that is negative 4/5. And to simplify this, 2 times 3 times negative 4 is equal to negative 24, and 5 times 5 is 25. Letter B, cosine 2 theta. So let's use the first one. So again, these are all equivalent. So let's use the first one, cosine squared theta minus sine squared theta. Cosine theta adjacent over hypotenuse, that is negative 4/5 squared, and sine squared theta opposite over hypotenuse, that is 3/5 squared. Negative 4/5 squared is 16 over 25. 3/5 squared is 9 over 25, and 16 minus 9 is 17 over 25. Okay, then so that is cosine 2 theta. Next, letter C, tangent 2 theta. So we know that it is equal to 2 tangent theta over 1 minus tangent squared theta. So tangent theta is -3/4 over 1 minus -3/4 squared. So let's simplify this. 2 times -3, -6/4 is -3 halves all over -3/4 squared is 1 minus 9/16. And that is, I'm gonna use this space here. So -3 halves over 16 minus 9 is 7. So 7/16. Then -3 halves, get the reciprocal of that, 16 over 7. And 16 divided by 2 is 8. 8 times 3 is 24. So this is -24 over 7. So these are the answers. Okay. Next, example number 2. Verify the following identity. 1 plus sine 2 theta is equal to sine theta plus cosine theta squared. Sine plus cosine theta quantity squared. So remember that this is the same thing as sine theta plus cosine theta times sine theta plus cosine theta. This time, let's use the right hand side. Let's show right hand side that is equal to 1 plus the left hand side 1 plus sine 2 theta. Okay, so with that, let's multiply this. Sine theta times sine theta is sine squared theta. Sine theta times cosine theta. So this and this is going to be equal to 2 sine theta cosine theta. Then cosine theta times cosine theta is cosine squared theta. And we know that this and this is equal to 1 by Pythagorean theorem, right? So that is 1 plus 2 sine theta cosine theta, and 2 sine theta cosine theta is one of the double angle formulas, which is equivalent to 1 plus sine 2 theta. Look at that. That is equivalent to the left hand side. Okay. Example number 3. Verify the identity to tangent to theta is equal to 2 over cotangent theta minus tangent theta. Now let's work on the left hand side, because we have tangent to theta that it is equal to, using the double angle formulas, it is equal to 2 tangent theta over 1 minus tangent squared theta. We can multiply both numerator and denominator by 1 over tangent theta. When we do that, So 2 tangent theta over tangent theta is just equal to 2. And then distribute 1 over tangent theta. So this is 1 over tangent theta minus tangent squared theta over tangent theta. And that's going to be equal to 2 over 1 over tangent using the reciprocal identity is actually equal to cotangent theta minus tangent squared theta over tangent theta is tangent theta. And look at that. This is equal to the right hand side. Okay. Alright, next one. We have the reduction formulas. We will also be using the following formulas anytime we want to reduce the powers of the sine and cosine. So again, that is by reducing the powers of sine and cosine. And you will use these formulas heavily in calculus. So these are the reduction formulas to remember. Sine squared theta is equal to 1 minus cosine 2 theta over 2. Cosine squared theta is equal to 1 plus cosine 2 theta over 2. Tangent squared theta is 1 minus cosine 2 theta over 1 plus cosine 2 theta. Okay, so example number 4. We're going to reduce cosine to the 4th x to a power of only 1. You can rewrite cosine to the 4th as cosine squared x squared. That means that is the same thing as cosine squared x times cosine squared x. Do you agree? And now we have cosine squared here. So that is equal to 1 plus cosine 2x over 2 and 1 plus cosine 2x over 2. If we multiply these two, 2 times 2 is 4, so that is like 1/4 outside. 1 times 1 is, or it's like 1 plus cosine 2x times 1 plus cosine 2x, isn't it? Then 1/4, 1 times 1 is 1, cosine 2x plus cosine 2x, that is 2 cosine 2x plus cosine 2x times cosine 2x is cosine squared 2x. Then this is now 1/4 1 plus 2 cosine 2x plus another cosine squared. So you could use again this reduction formula. So that is now 1 plus cosine 2 theta. So 2 times 2x is 4x over 2. Then we can rewrite this as 1/4. This is like 2 over 2. This is 4 over 2 cosine 2x plus 1 plus cosine 4x over 2. So as you can see now, they have all the denominator of 2. So 1/2 times 1/4 is equal to 1/8. And this now 2 plus 1 is 3 plus 4 cosine of 2x plus cosine of 4x. So now this is the answer. Look at that. The cosine has only a power of 1. Okay, let's try another example. Example number 5. Use power reduction formulas to prove sine cube 2x is equal to 1/2 sine 2x times 1 minus cosine 4x. So let's use again the left hand side for this. And sine cube 2x, we know that that is, we can rewrite that as sine squared 2x times sine of 2x. And we know that sine squared is equal to 1 minus cosine of 2 theta. So 2 times 2x is 4x over 2 times sine of 2x. Alright, and that is equal to, we have here over 2 and sine 2x, so that is like 1/2 of sine 2x times the numerator 1 minus cosine of 4x. So that is the same as the right hand side. Okay, next, half angle formulas. We will also be using these the following identities anytime that we have half an angle. So these are the half angle formulas. Sine alpha over 2 is equal to positive negative square root of 1 minus cosine alpha over 2. Next, cosine alpha over 2 is plus or minus 1 plus square root of 1 plus cosine alpha over 2. And the tangent, these are all equivalent to that. So note that we use the plus or minus depending on which quadrant alpha over 2 exists, and whether sine, cosine, tangent is positive or negative in that quadrant. Let's try an example. Example number 6. Find sine 15 using half angle formula. So sine 15, we can rewrite this as sine of 30 over 2 degrees, right? And then now we can use our formula. Sine 15 is in quadrant 1, so it's going to be positive. So that is square root of 1 minus cosine of 30, our alpha is 30 over 2. And what is cosine of 30 degrees? So again, this is 30 degrees, and we know that the coordinates square root of 3 over 2 and 1/2. So cosine is square root of 3 over 2. So this is equal to square root of 1 minus square root of 3 over 2 over 2. And that is equal to 2 minus square root of 3 over 2 all over 2. And let's simplify this more. It's going to be 2 times 2 is 4. So that is square root of 2 minus square root of 3 over 4. And square root of 4 is 1/2. So we can get that 1/2 times the numerator square root of 2 minus square root of 3. So this is the answer. Okay. Alright, now let's try to answer some lecture questions. Number 1, for the following exercises, find the exact value using the half angle formulas. For A, cosine of 7 pi over 8. You can think here of alpha is 7 pi over 4, and use cosine 7 pi over 4 over 2, because 4 times 2 is 8. And now 7 pi over 8, cosine is positive and is in quadrant 4. Okay, so this is in quadrant 4 and cosine is positive. So that's going to be equal to square root of 1 plus cosine of 7 pi over 4 over 2. And cosine in quadrant 4 is positive, and that is equivalent to square root of 2 over 2 over 2, which is equal to square root of 2 plus square root of 2 over 2 all over 2. Again, 2 times 2 is 4, so that is square root of 2 plus square root of 2 over 4. And now the answer, square root of 1/4 is 1/2. I don't have space. Square root of 2 plus square root of 2. So that is letter A. I'm going to use this space for letter B. Sine 11 pi over 12. So here, like what we did for letter A, we can have alpha is 11 pi over 6, so that we could use sine of 11 pi over 6 over 2. But this is also in quadrant 4, and sine in quadrant 4 is negative, so let's use that. So this is equal to negative square root of 1 minus cosine, our alpha is 11 pi over 6 all over 2. And I want you to simplify this. 11 pi over 6 is equal to square root of 3 over 2. All over 2. And again, sorry, I don't have a space here, just like what we did here. So follow that and you will be able to simplify the answer. Okay. All right, number 2. For the next 2 problems, use the following triangle in figure 5 and the double angle formulas. So your alpha here, your theta, 5, and this is 12. So we can solve for the hypotenuse. So that is 5 squared plus 12 squared is equal to c squared. 144 plus 25 is 169. C squared, square root both sides, so c is equal to 13. So this is 13. Now we want to find number 24, sine 2 theta, cosine 2 theta, and tangent 2 theta. If this is your theta, so this is the opposite side, this is the adjacent side, and this is the hypotenuse, the 13. Okay, so sine 2 theta using the identities double angle formulas. So sine 2 theta is equal to 2 sine theta cosine theta, and sine theta is SOHCAHTOA, opposite over adjacent, so 5/12 times cosine adjacent over hypotenuse 12/13 over 13. So here sorry, this is 5/13. Hypotenuse is 13. Okay, so 2 times 5 times 12 is 10 times 12 is 120. 13 times 13 is 169. So this is the answer. Cosine 2 theta is equal to, you can use cosine squared theta minus sine squared theta. Cosine again is adjacent over hypotenuse, that is 12/13 squared, minus sine squared is 5/13 squared. So that is equal to 12 squared is 144 minus 5 squared 25 is 119 over 169. Okay, and for tangent, tangent to theta is equal to, we know that this is equal to 2 tangent theta over 1 minus tangent squared theta. So this is 2 tangent is opposite over adjacent, 5/12 over 1 minus 5/12 squared. So I'm going to use space here. So that is equal to 2/12 is 6. So this is 5/6 over 1 minus 5/12 squared is 25/144. So this is 5/6 times 144 minus 25 is 119/144, and reciprocal of that is 144/119, and just multiply across is gonna be equal to 720 over 6 times 119 is 714. So this is the answer. Okay, and I'll let you try with number 25. This is sine 2 alpha, cosine 2 alpha, and tangent 2 alpha. Do the same thing, but this time you're using the angle alpha here. So this becomes your 12 is now the opposite, and 5 is the adjacent with the same hypotenuse, 13. Okay, practice that. And now the last problem. Number 3, use the power reduction formula to rewrite the expression cosine squared 5x. So again, I'm going to rewrite it here, cosine squared 5x. So cosine squared, we know that that is equal to 1 plus cosine 2 theta over 2. So that is just simply 1 plus cosine 2 theta, our theta is 5x, is 2 times 5x is 10x over 2. So we can rewrite this with the power of 1, which is equal to 1/2 of times 1 plus cosine of 10x. So this is the answer. Okay, so that's it for section 7.3. Let me know if you have any questions. Thank you.